everybody. Welcome to another problem session. So I've been a little busy lately. So I found this actually good problem, and let's do this problem today. So going back to the actually projectile motion part, I know we've done that before, but this is a really interesting problem. So you shoot this, and you start from some point P, and which is a height h below the peak of this roof, and you shoot it, and then it lands over here, but it just clears here. Just clears here. So, and this height, and from here to here is h, and here to h. So the height and the range are kind of related. Okay, it's symmetric, so you can set it up just this point R. That point S, R is almost the same as S, right? Those points are very infinitesimally close, so we just, R's height is same as H, so I can just say H. All right, so that's the interpretation of the problem. And the question is, what is the velocity? What is this, and what is this? So those are two questions. What is the initial speed must ball thrown to that just clears the peak other side of the roof height. It doesn't ask for the angle, but angle will be part of the answer. Okay, so I would have kind of make it initial velocity. I'll modify this question. All right. There may be several ways of doing it. So this is the initial point. That's at t equal to 0. And this is the final point in this whole journey, right? But it kind of misses the information that he has to clear over there. So if you say this is my final, then I would miss the point of it being at this point in time is going to be over here. So instead of using this final, I'm going to just look at this as the final. Okay, that's going to call T. All right, and so we just motion P to R. So instead of axis over here, we're going to do axis over here. Y-axis this way, x-axis that way. And so assuming V0, so V0x just going to be V0 cosine theta 0. V0y is V0 sine theta 0. And at this point, velocity is pointed all along the x-axis. So this is t equal to 0 situation. And t equals to t situation is Vx is V0 of x. You already know because the acceleration is acceleration along x is 0, and Vy is 0 because acceleration y equals to minus g. Okay, so this slowly comes down. And x0 is 0 and y0 is 0 at that point. And at that point we also know x is h and y is h. So we don't know anything more, just this. Okay, and this embodies all the points that I need to embody. Okay, so time between this to this is t, which is already stated. So now let's write on what we're going to go. Along the x-axis, we're going to get only one equation. So it's going to be how much distance it traveled along the x-axis with that speed, okay, in time t. All right, so x minus x0 is x minus x0 equals v0 x t plus 0. So this just simplifies to h equals to v0 cosine theta 0 times t. So that's going to be equation number 1 for us. An important question. And along the y-axis, it's going to get 2 equations. So 2 equations we're going to get is 1y minus y0 equals to v0 yt plus half ayt square. And using our thing here, sets this h will be equal to v0 sine theta 0 t minus half gt square. So this is equation number 2. Okay. How about another equation from here? So vy equals to v0y plus ayt, constant acceleration, right? So this just gives me 0 equals to v0 sine theta 0 minus gt. So this equals number 3. So here at this point we can proceed several ways. You can see already what's unknown here. If you look, you have unknown is v0, you have a theta 0 and t. These are unknowns, and we have 3 independent equations. So it's a matter of kind of crunching out the algebra properly. So this one, let's see, get rid of t from every one of them, get rid of t from all of them. So this, we can take this as a t, or this is a t. So the t is v0 sine theta 0 over g. Let's say this t will be h0 over not h cosine v0 cosine theta 0. So this is the same amount of time, and whether, let's see how what goes. And this one is like a quadratic, so I don't want to solve for t. So either of these, making them equal, let's see what that gives me. v0 sine theta 0 of g equals h over v0 cosine theta 0, and bring it over that side. So I get a h equals to v0 square sine theta 0 cosine theta 0 over g. So this is for h, and there's another one for h. Maybe we can make it equal to that, and that maybe give me a condition to solve for something. So that is a possibility. Okay. So one of these we can put for t, and okay, so let's see. So we have a h equal to v0 sine theta 0, and so t is this guy. You can put this guy, but let's put that guy, because h might cancel out. V0 cosine theta 0 plus that's actually minus half g h over v0 cosine theta 0 square. So the h kind of cancels out from every one of them, and so I might get another relationship here. Okay, so what do we have? So 1 equal to just tangent theta 0 minus g h. This is square, so it's on the h cancel, not every h. b0 square cosine square theta 0. So you can see this. I really didn't make that much progress using this guy. How about that guy using the other guy? H is equal to, so I still got this guy, two unknowns in the same equation. So I got a v0 sine theta 0 and okay, so I'm looking at this, maybe can make progress, but this v0 here was cancelled out, but v0 here remained. So over here, let's see v0 sine, so using this guy now to see if we get somewhere. So v0 sine theta 0 over g, and then we have a minus half g v0 sine theta 0 over g square. So this one actually is pretty useful. It looks like to me. I have a v0 square over g sine square theta minus half v0 square over g sine square theta 0. I should have used just the theta. I'm just kind of didn't make a choice. Maybe theta, let's call it theta 0 from now on, because I'm getting tired of writing theta zeros. So this is half v0 square over g sine square theta. So you have expression for h here, another expression for h here. So this, equating these guys should be, so let's call it, this is 4 and this is 5. Half v0 square over g sine square theta and v0 square over g sine theta cosine theta. So how do we solve this problem? So this is, we need to find first theta, and from there we can get the v0. Okay, so we multiply both sides, you get a sine square theta equals to 2 sine theta cosine theta. You know, you can at this point proceed several different ways, right? You can say I'm going to do bring this on this side. You can say sine theta minus 2 cosine theta equal to 0, and we're going to shoot like this. So this theta is definitely greater than 45 degrees. This was 45 degrees. So so this can not be this cannot be 0, then this has to be 0. So let's solve this. Sine theta equals to 2 cosine theta, and here clearly you can square it. Let's call it x equal to cosine theta, then square root of 1 minus x square, and this is 2x. The square both sides, 1 minus x square equals to 4x square. So I get a 5 x square equals to 1, then x square equals to 1 over 5, and x equal to r cosine 1 over 5, and what will be the plus or minus? So plus too much jumping, okay? So this is x equal to plus or minus 1 over square root of 5. So cosine theta is plus or minus 1 over square root of 5. So if you look at cosine theta is all positive here, negative here. So this is like plus or minus 1 by like 2.2 or something like that. So this could be, you know, b over h. So if you look at this angle here, so base over height, right? So this so it's something like this over here, or over here. So either this angle or this angle. So if I'm going to go this direction, then I need this angle, not this angle will just take me that direction flight, you know. So the minus is not the case here. So cosine theta is plus 1 over square root of 5, and so theta is r cosine 1 over square root of 5. And so you have to kind of look it up. I don't know what the value will be of any degrees. So that's it. I hope I didn't make a mistake here. It's easy to kind of, when you're doing 1 over 2 here and doing too fast, you might make some kind of goofy error. But overall, the process is pretty instructive. So I will see you in another video. Bye.